Hello friends, my name is Habib. Today we are going to learn how to create a basic platformer game using Godot. So first, open up your browser and write godotengine.org. It is going to take you to the official Godot website. And now click on download latest and then click on Godot engine. So anyways, if you're wondering what this is, well, this basically allows you to code with C# in Godot engine, and this is you can't code with C# in this version, but since we don't want to code with C#, I'm going to click on here since I don't want to code with C#. So anyways, once Godot has finished downloading, click on it and it is going to download as a zip file. Then click on extract and then extract it to wherever you want. But since I've already done that, I'm not going to do it since I've already extracted Godot. So once Godot is extracted, you will see this file in wherever you extracted it in. Now double click on the file and it is going to open Godot engine. Let me close this since I don't need it. Also close this. Now click on the Godot engine and click on new project and name it platform. And it basically allows you to create a new project. But in this basic platformer, we're not going to be adding sound effects or animations or level progression. It's just going to be one level without sound effects, no level progression, and no animations. Now, project path. Click on browse, go to the documents, create folder and name it platformer. Okay, select current folder and the folder must be empty. If you want to create your game, the folder you create your game in must be empty. And you'll see that there are three options: forward plus, mobile, and compatibility. Forward plus, it is for people that have high-end PCs that use Vulkan graphics. Forward plus is for very high-end PCs. On mobile is for mobile games, and compatibility, it allows you to create games that is compatible with your PC. And since I don't have a high-end PC, I'm going to click on compatibility. Create and edit. Now you'll be greeted with this. This is a 3D scene, but we want to create a 2D game, not a 3D game. So click on 2D. And when you click on 2D, you'll be greeted with this. Now click on Ctrl- to zoom out. And this square is basically the viewport. Anything in this square will be visible, but anything outside this square is not going to be visible unless you have a camera. So everything you're going to be doing is going to be inside of this square. So now we can create a 2D scene. A 2D scene is basically like a level. Now you can save it as level.tscn. Now scenes. Scenes aren't just leveled. The scenes can be anything. Scenes can be your player character, coins, they can be collectibles, enemies. Scenes can be anything, including levels. So now, but the reason why I created this scene is for level. This is the level scene. So now click on add node, and then add a static body 2D. A static body 2D is something that never moves. Static body 2Ds will never move in your game. And then add a polygon 2D. Polygon 2D allows you to draw things with points. So I'm going to draw a basic level. Very basic level. No, I'm going to zoom out. Now we have a very basic level. This static body 2D is basically, it never moves in your game. Static body 2D is going to stay in one place forever. Create a new node, collision polygon 2D. Now the collision polygon 2D, it's what allows things to collide with your level. It is basically, without collision polygon 2D, then things are just going to be falling through this. So since the collision polygon 2D allows things to collide with this, make the collision polygon 2D to be the same shape as your level. And now, there, we've go. So now, we can play this by choosing this. And now you will see, let me zoom this out, that we have a basic level. But even though we have a basic level, there's nothing interesting about this level. I mean, it's literally just staying in one place. Remember how I told you before that scenes can be anything? I'm going to create a new scene for the player. You can either choose a 2D scene. A 2D scene is basically for 2D levels. If you want to create a level, then you have to use a 2D scene. A 3D scene for 3D levels, user interface. And then node. And this will allow us to choose that node we want. I'm going to choose character body 2D, and then I'm going to name this scene player. Character body 2D basically allows you to create characters, or it just allows you to create anything that is moving. So if you want to create an enemy, then you can use character body 2D, or if you want to create an enemy, you can use character body 2D. Basically, character bodies 2D can be anything. They can be collectibles, enemies, players. But character body 2Ds are generally used for things that are moving, like enemies or players. Things that can actually do things. So since our player can actually do things, I'm going to use character body 2D. New. I'm going to use a polygon 2D to draw the player sprite. And then collision shape 2D. Collision shape 2D is what allows things to collide with this. Collision shape 2D is the same as collision polygon 2D, except that we don't get to draw how the things will collide with it. We have to use a bunch of preset shapes. So anyways, but since I don't want it to be this, I'm going to open GIMP for actually drawing the sprites. Now you can draw a sprite in any photo editor that you want, in any drawing editor that you want, but I'm just going to use GIMP, since it's the one I'm familiar with. And then I'm going to draw a simple player character. Now you can use any drawing app you want for this. And now I'm going to export it. Put as layer.png pictures and then export. Now go to Godot engine and to import the player sprite, to this, go to documents and then go to pictures and then drag the player sprite here into the engine. Then you'll see we have a player.png. Now drag the player.png into the player scene and delete the polygon 2D. Now this player is kind of big, so because of that I'm going to reduce its size, make it smaller. There we go. Now the player is very small. And now I'm going to make the collision shape 2D to be the shape of the player. Since the collision shape 2D is what allows the player to collide or interact with other things. Now I'm going to drag this player scene into my level. Now you will see that yes, we have our player, but the player isn't doing anything. It is just floating in one place. That is because you have to create a script for the player. A script is basically tells the player what to do. Like if you want the player to move right, you have to create a script to tell it to move right. To create a script, click on the node you want to create a script for. Click on this thing you want to create a script for, and then click on this button, res/player.gds, and create. Now just ignore this, because if we delete this, then this script is not going to be working anymore. Just ignore it. It's not important right now. So anyways, now we want our player to be falling, so write func_physics process move and slide velocity.x mean velocity.y plus equals 20. What this basically does is that physics process, it runs every single frame, so it is going to do whatever is here every single frame. Move and slide, it allows you to use two variables, velocity.x and velocity.y. If you use this without move and slide, then it wouldn't work. And the velocity.y is basically the speed of the player on the y-axis. And this velocity.y plus equals 20, it increases the speed of the player on the y-axis by 20 every single second. So now if we run this, you will see that our player falls and hits the ground. That is cool, but there's nothing cool about this. I mean, we can't actually control the player, so what's the point? If you want to control the player, go to project settings, and then input map. Add new action, and input map is basically allows you to add input to your game. So like if I want the player to, so that if I want to make it so that if the right arrow key is pressed and the player moves right, I'll add a new action, naming it right. Click on this plus button and then press the right key. Okay. And then I'll be able to use this action in our game. Then I'll be able to use this action in my game to make it so that if this key is pressed, which is the right key, then the player will move right. I'm going to make a new one called the left key, plus, click on here, and then click left, okay, and I'm lastly going to add another action called jump, enter, press this plus button, and then press the key that you want to use for jumping. The key can be any key, but I want to use space for jumping, so I'll press space, okay, and then close. Let me save this. So now, to make it so that if the player presses right, then he's going to move right. If then input.is_action_pressed right velocity.x plus equals 20. What this basically does is that if the right action is pressed and the right action is the right key, so if the right key is pressed or held, then the speed of the player on the x-axis, which is velocity.x, is going to be increased by 20 every single frame. So now you see, if we press right, the player is going to accelerate. Because if you press right, then the speed of the player will be increasing by 20 every single frame, which will make acceleration. But what if we don't want any acceleration? If you want the player to move at a constant speed, then write velocity.x equals and whatever speed you want. So this means that when the right key is pressed, then it sets the player's speed on the x-axis to 200. You'll see that when we do that, there's no acceleration. It just moves with a constant speed. But I'm going to write plus equals 20 since I want acceleration. Now, currently, we can only move right. But what about left? So write elif inputs.is_action_pressed left, then velocity.x minus equals 20. What this means that if the right action is pressed, which is the right arrow key, if it is pressed or held, then the player's x velocity or x speed will be increasing by 20. Else, if the left action is pressed or held, which is the left arrow key, then the player's speed on the x-axis will be, and then the player's speed on the x-axis will be reducing by 20. Now, if I press left, then the player will move left. This is cool, but you see that if once the player starts moving, the player does not stop. It continues moving forever, even if it's about to fall off a cliff. So, write else velocity.x equals lerp f velocity.x, 0, 0.1. Now you're going to be finding that you're going to use this lerp f a lot in your games. What this basically means is that if none of these conditions are true, as if the player is not pressing right or left, then the x velocity is going to be set to 0. So you might be wondering, why do we use this lerp f? Well, this lerp f, it basically transitions the velocity from the current velocity to 0. Well, now you see that with lerp f, if I move and then I release, it is going to slide a bit before it stops moving. But if I just write velocity.x equals 0, then you will see that the player feels very stiff. It just stops immediately and it doesn't feel natural or good to control. This lerp f basically tweens this velocity from the current velocity to 0. And this is the weight. The smaller the weight is, the more slippery your player will be. The player is very slippery since I set the weight to a very small amount. But if I set it to a very big amount, then the player will not be very slippery. Instead, be very hard and solid. Enough of explaining what lerp does. How do we actually make the player jump? Right. If then input dot is underscore action underscore pressed jump, which means if the jump action is pressed, and the jump action is basically the space key, so this means if the space key is pressed or held, then velocity dot y equals minus 600. Now you see that if we press the space key, then the player is going to be moving upwards. But you see a problem. The player can just fly. So you have to write if is action underscore just pressed. What just pressed does is that if the action is pressed, just pressed will only register the action if it is pressed. If it is held, then it won't register it. Now you see that if we press space, we can't just hold it and be flying. Now this game feels a little bit like Flappy Bird. But we want it so that if the player is on the ground, then he'll only be able to jump if he's on the ground, not when he's in the air. So write and is underscore on underscore floor, which means if the jump key is pressed, which is space, and the player is on the floor, then the player will jump. Now you see that we aren't able to fly like we were able to before. So now, what velocity of y equals minus 600 does, it's basically that it sets the player's speed on the y-axis to, it basically sets the player's speed on the y-axis to negative 600, so the player will go up. Yes, this is all good, but the method we're using is pretty inefficient. It's better to use variables. To create a variable, write var and then the variable name is equal to a value. If you're familiar with programming, then you would know what variables are. Variables are basically used to store information. So, like, if I want to store the player's speed in a variable, I'll just write var spd equals 20, then plus equals spd, and minus equals spd. So now, if I wanted to set the player's speed, I won't have to set it manually for each of these if statements, and instead I could just set the variable. And now, if I wanted to set the player's jump height, I'll create a variable named jump height and set it to minus 600. And then I'll write velocity.y is equal to jump height. Now this is a way more efficient way of doing things than the other way. So I can also write at export var spd equals 20, which will allow me to set the variable here in the player's properties. If you didn't know that these are the player's properties, at export allows me to set the player's properties, the variables here. Now I'm able to set the speed and jump height. I can set the speed to something like 100, and the player will be faster than Sonic. So, but let me just set it to 20. Anyways, we've got a basic platformer, but this platformer is kind of boring because all we have is a player that can jump. We don't have any enemies or collectibles. So the next thing we're going to add is collectibles. Create a new scene for the collectibles. Coin. And this coin is going to be a character body 2D. Okay. So now, a character body 2D. I already told you before is that a character body 2D is a node that can do things like a character body 2D can be the player, it can be a collectible or an enemy, but it can't be a level since levels don't actually do anything. I'm going to create a character body 2D and then open up your photo editing program and create a coin. Now I'm going to create a coin in GIMP. Okay. And then I'm going to export the coin. Export as coin.png. Export. Export. And now the coin is exported. So if you want to import the coin into our game, pictures, and then drag the coin into the Godot engine. Close again. And then I'm going to drag the coin.png here. Make it smaller. And now we have a coin. Make the coin even smaller. And I'm also going to add a collision shape 2D. Now, I told you before that a collision shape 2D is basically what allows things to interact with it. I'm going to make the collision shape 2D just to be the same thing with the coin. Turn this into a capsule shape. Increase its size. There we go. Now I can drag this coin into our level scene. Coin.tscn. I can drag it into our level scene. Coin, and coin. But you'll see that there is a bit of a problem with these coins. Now if I play my game, we won't be able to collect the coins. We're just going to be colliding with the coins. So turn the coin. I'm going to remove the collision shape 2D so that the player won't be able to collide with it. So now you see another problem. The player will just go through the coins. If the player touches the coins, the player won't actually collect them. So we have to create an area 2D. No, not that. Area 2D. And then create a collision shape 2D. Make it a capsule shape. And then make the capsule shape to be like our coin. Now you see that this on its own, it doesn't do anything. No, this area 2D on its own doesn't do anything. But when we get to the coding, it's going to be very useful. I'm also going to add an area 2D to the player. I'm going to name this area 2D player. Duplicate this and put it here. Save. And I'm going to name this area 2D coin. Coin underscore box. So now I'm also going to create a script for this coin. Create a new script. Coin.gd. Create. And now I'm going to write func_physics process delta. Then in this func_physics process, I am going to write nothing, because click on the area 2D that we just made, click on node, and you're going to see all these. These are signals. You can double click on one signal. This area underscore entered means that if anything enters this area 2D, which is basically this collision shape 2D, if anything enters this collision shape 2D, this area 2D, then something is going to happen. So double click on area underscore entered, connect. So now write if then area.name is equal to, go to player, and the name for the player area is called player 2. Player 2, then print colliding. Print colliding like this. Save. Oh yeah, pass. Now, if we don't want this something like that to happen, then if there's an empty function or an empty if statement, just put pass. So now I'm going to do this. Now I'm going to touch this, and then it's going to say colliding. Since this area's 2D name is player 2, and then this coin's area 2D is touching the player's area 2D, it is going to say colliding. So now, instead of that, I'm just going to write q_free. So I'm in the coin scene. I have to be in the level scene. No, play. And now, if I touch the coin, it is going to disappear. But the coin is a bit boring. I mean, it just stays in one place. So to fix that, write var t equals 0, and then t plus plus. So wait, t plus equals 1. And then write coin.position dot y is equal to sin t. I mean position.y is equal to sin t. And now you will see that our coins will be doing this. Let me set this to plus equals sin t, so that won't happen. And now you see that our coins will be flying a little bit, but they're just flying a little, so I'm going to write sin t times 3. And our coins will be flying, and our coins to be flying much more higher. 5. But we want this to be a little bit slower, so I'm going to write sin t times 0.2. And then you'll see that this is very smooth. Anyways, that is it for today's video. Hope you enjoyed it. Subscribe to my channel, ObaCode. Bye!